Hello, you asked for what a minimum spanning tree is and how to draw it, so I have an example here. A minimum spanning tree is basically the smallest tree you can build with the lightest weight. Okay? So notice how each of the branches has a number associated with it. Okay? And when we draw a tree, let's say I'm going to draw a tree in the color red, okay, using this one, A to B, A to C, A to D, A to F, and A to E, like that, right? The tree's weight would basically be when you add up all of these numbers along the branches. Okay, so in this case it would be 2 plus 8 plus 6 plus 7 plus 6, which is equal to 10 plus 13 plus 6, which is equal to 29. Okay, so for this tree here in red, it would be 29. Now, a minimum spanning tree is a tree that has the lightest weight, so the smallest weight. Okay, now the way that we find that, it's two ways. You can either use Prim's algorithm or Kruskall's algorithm. Now for this example today, I'll only be showing you how to do Prim's algorithm. If you want to do Kruskall's, you can look it up in your own time or you can ask me later. Anyways, the way that we do Prim's algorithm is, number one, you start at a point. I'm going to say point A. Now what you do with point A is that you look at each of the branches it can go to. We have this one, and this one, and you find the smallest weight. So for our example here, from A, we currently have 2, 5, and 6. 2 is the smallest, so we take that one. So remove the 5, remove the 6, and keep the 2. Okay, so I'm going to draw a line along that edge because I'm taking that line. Okay? Now, we move to our next step. Okay, which is now, we look at A and B. So look at all the branches you can go from A, which is this one here, and this one here, and look at all the branches from B, which is this branch here and this branch here. And what you do is you pick the smallest one. So we got 8, 6, 5, and 6. 5 is the smallest, so we keep that one. We rub these out. Okay, so we take that 5 edge there, right there. Okay, which would be this line right there. Okay, now we move on to our next line. So now the points we're working with are A, D, and B. So we're going to look at all the lines from A, which is this line right here, all the lines from B, which is this line here and this line here, and all the lines from D, which is this line here, and those 4 lines there. Now let's look at how heavy they are. We've got 1 6, another 6, 1 8, 1 3, 1 7. Okay, and this one here would be a 6. Alright, 1, 2, 3, 4, 5, 6 numbers to pick from, and 3 is the smallest. So we take 3. So we rub all the other ones out because we don't need it. Okay, and we only take that number 3 there. I'll just redraw this one in. Okay, now we do the same thing. We have a new point now, C. So we look at all of the branches going from A, which is this one line here. I should pick a better color. Oops. Let's close that. Okay. Now we look at all the lines going from A, which is this line here. All the lines going from B, this line here and this line here. All the lines going from D, which is this line here, and this line here. And all the lines going from C, which is this line here and this line here. So we circle the weights that we're using. Okay, and then there's 5 up there, and then we pick the smallest one, which in this case is 5. Okay, so we rub the others out because we don't need them anymore. Okay, rub it out. Alright, so we've taken this line here with the 5 on it. So I'm going to draw a line with that 5 right there. Alright, so now we have 1, 2, 3, 4, 5 points, and we're missing our last connection to the 6th one. So we're going to fix that right now. Okay? Now, do the same steps. We look at all the lines, okay, from our points that we have. Look at all the points from A, from B, C, D, and E. Okay? 2, 6, 7, 6, 6, 8. Okay? Pick our smallest number. In this case, it's 2. So we take that one. So we rub all the others out. Rub that one out. Just fix this one. Okay? And we take that line there. Right there. And with that, what we have is a tree, because a tree, remember, has every single vertice in action. If I'm missing one vertice, it's not a tree. Okay? So we're using all of our vertices, all of our letters here. A, B, C, D, E, and F. Okay? So now we have our tree. What we do now is that we add all the numbers up together. So the numbers that I've circled, we're going to add them up now. So it'll be 2 plus 5 plus 3 plus 2 plus 5, which would give us 7 plus 5 plus 5, which would give us 17. So our answer here is 17. Okay, for our minimum spanning tree. Now again, this is only one of the ways to do it. There's also Kruskal's algorithm, but the thing with Kruskal's algorithm is that it's a bit different from Prim's. So if you want to learn what that is, either ask your teacher, or if you're still confused, you can ask me. Anyways, I hope that helps. I'll see you later.